Hi everyone, welcome to Python for Academics. In this video, we'll start building a Python toolkit that can help you in post-processing research results. In the first exercise, I'm going to show you how you can prepare your Python script for post-processing data that arrives asynchronously. So imagine that you are running a set of 20 cases on a cluster. They're each indexed with a number between 1 and 20, but that each can finish running at different times. Maybe some cases can even fail and not produce any results files. So ultimately, at any given time, you might only had a handful of those results to post-process. And we'd like to prepare your post-processing script to handle the missing cases, but already start running the post-processing for the results that have finished. Now this is especially useful if your post-processing takes a long time to run. So you'd like to run your post-processing script only once on each of these finished cases, and you don't want to post-process the same case multiple times because that, for example, takes a lot of time and a lot of computational resources. So we're going to start by generating a couple of empty results files, just so that we simulate this condition over here that we have 10 result files, but since they arrived asynchronously, they might have some missing cases. So we're going to specify the number of cases that we're going to have in total once all the results have finished running. Let's say that's 20. And now we're going to create a list of indices that have finished running. I'm going to create a random selection of indices between 1 and 20 without repetition, and we can do that using the NumPy function random.choice. So we can specify the range from which we're going to select our numbers. So this is between 1 and number of cases plus 1. We have to add 1 so that the last number that we can select is 20. And let's say that we're only going to select 10 integers from between 1 and 20. And in order to select without repetition, we're going to set this flag replace to false. And now I'm going to set the output of that random.choice function to this variable completed runs. So now if we look inside of that array, there are 10 integers between 1 and 20 without repetitions. We can also print them in the sorted way with a sorted list of sorted integers, just so that we see clearly which cases are missing. So now I'm going to generate the 10 results files that are indexed with these numbers, and we're going to do that by looping over for I in completed runs. We're going to open a file, but just for file creation. This is what the X specifies over here. We're going to open a file in this location, data. So we need to specify the relative location with respect to this Jupyter notebook. And then to match the pattern of those file names, we're going to write hydrogen case, and then we're going to add the index. And I'm also going to pad this index with zeros to match a 2-digit pattern. And at the end, let's say we're going to add some extension, file extension. Let's say these are going to be CSV files. So now if I run this and we wait a little bit, now we have those results files created over here. So this is just a starting point for our exercise, just to have this situation simulated. So imagine you downloaded those results from the cluster, for example, and there are some missing cases. So for example, 1, 2, 6, 8, those are missing cases which have not completed yet. So now we're going to prepare any Python script that does some kind of post-processing of those results. we're going to prepare it for handling this situation here, and we're going to use the OS library because we're going to be using os.path.exists function from that OS library. And now we're going to loop over the cases that we have in our complete run. So for case in range from 1 to n cases plus 1, so we'll loop over all of the 20 cases. And now we're going to check if the results file is already present. So if os.path.exists, and now we're going to specify the file name for those results files. This is the file name, but now we use case as an index. So if that file already exists, we're going to do the post-processing, but else if that file does not exist yet, we're just going to print some information that this case has not finished running. So maybe we're going to print case and then the case index. Let's say we're going to print case is not there yet. But if this result file already exists on your machine, we're going to now check if the post-processing output file already exists. So if we've already run post-processing on that particular case, we're not going to run it again. But if we haven't run it yet, we would like to run it. So now we're going to be checking if the post-processing output file is already in that location. So if it's not in that location, so if not os.path.exists, it's not in that location, then we're going to run our post-processing script. And there can be a lot of code that you can put here, whatever post-processing that you need to do on your results file. But if that file already exists, then we're just going to print some information again. So we're going to print maybe we're going to print that case, and then the case number is already post-processed. Okay, so now if this file exists, we might also want to print some information that we are now proceeding to post-processing that case. So post-processing case and then the case number. And ultimately, after a lot of post-processing has been done, we're going to probably be saving the output of our post-processing to a file. And this is the file that we're going to be also checking over here. So I'm going to save that file with the numpy function save txt. And this is going to have, let's say, similar pattern to the file name. It's just that we're going to add post-processed prefix to that file name, and then we're going to specify the variable to save. So if, for example, you're computing some metrics as part of your post-processing, then you might be saving that metric over here. For the purpose of this exercise, I'm just going to save the case number because I don't have anything better to save over here. But of course, in your case, you're going to be saving some meaningful output of all of your post-processing that goes on over here. And I'm just going to specify the delimiter. If this is an array, then what's the delimiter for how different elements in that array are stored. And we're also going to specify the format. So let's say we're going to save this as a 16-digit float. And now over here, we are actually checking for whether this file has already been created or not. So we have to put this file name over here. So now if that file is not there yet in that location, our post-processing script is going to run. Otherwise, we'll print this message that this case has already been post-processed. And we have some error here, so I forgot a colon over here. Okay, so if I run this code, you can see that it tells me case 1 not there yet, case 2 not there yet, but we are post-processing case 3, 4, 5, and so on. So it looks like our script would run in all of those cases for all of those integers where the results are already there. And you can see that we have generated the output of the post-processing script. So in our case, these files just store the case number as a 16-digit float, but of course in your case you will be storing a meaningful output of your post-processing file. So now just to complete this exercise, let's say that we are going to, after a while, we're going to collect all of the remaining results from the cluster, so all of those cases that have not been there initially. And to generate those results files, just for the purpose of this exercise, I'm going to use a list comprehension to write a list of integers for those missing cases, and we're going to do that in the following way. So we're going to say I for I in a range from 1 to n cases plus 1, but only if I is not in the completed runs, so the array that we had before. And now I'm going to save this to some new variable. Let's say we're going to call this remaining cases. Okay, so now if I show you what's inside of that file, then you see the integers for all the cases that have not been there initially. And let's say now they finished running, you brought those results over to your machine. So we're also going to create those files. I'm going to copy that part of the code. We're just going to replace this with the remaining cases. So now if I run this and we wait a little bit, then we're going to see those files showing up over here. Okay, so we have all the remaining cases. Now we have 20 results files over here. And now if I go back to this code that we've prepared and I run it again, you can see that the output messages have swapped. So we see that we are post-processing case 1, post-processing case 2. Those are the two cases that have just arrived. We just created them. And then we also see that case 3, case 4, case 5 is already post-processed. That's what we've done in the previous step. And now if we also scroll down over here, you can see that all of those outputs of our post-processing script have been generated.